Welcome, folks. Today we are discussing a combined experimental and computational study of flow blurring atomization in a twin fluid atomizer. Let's dive in.
So this study uses a twin fluid pneumatic injector, right? Can you explain the setup and what they were trying to achieve?
Yes, it's a coaxial system with liquid and air streams mixing just before the outlet. The key is the gap between the orifice and the liquid tube. That gap dictates how the atomizer works. They were investigating two distinct modes, flow focusing, FF, and flow blurring, FB, and how the transition between them happens.
I see. And how did they investigate this transition?
They used optical visualization to observe the transition from FF to FB, but it didn't stop there. They also used LES, large eddy simulation, with a volume of fluid, VOF, approach to model the internal two-phase flow mixing, especially the backflow recirculation in the FB mode.
So, they validated their simulations, I presume?
Exactly. They validated the simulation results, specifically the length of the backflow recirculation in the liquid tube, against their experimental observations. This is crucial for the reliability of their model. It's a pretty rigorous approach.
What were the key findings? What did the simulations reveal about the atomization process? The simulations showed the formation of multiple microjets in the FB mode. This explains why previous studies reported a lack of a core jet and a nearly uniform radial distribution of the solder mean diameter, SMD. They even used a high-resolution backlit image of a larger transparent injector to confirm these numerical results. It's quite compelling evidence. So, the gap between the orifice and the liquid tube is the critical parameter, influencing the atomization mode and ultimately the droplet size distribution. That's a significant finding, isn't it? It seems like a relatively simple setup, but the underlying physics are quite complex.
Absolutely. The study highlights the importance of understanding the internal flow dynamics for optimizing twin fluid atomizers. The combination of experimental and computational methods provides a comprehensive understanding of this complex process. Thanks for joining us today, folks. Goodbye.